Okay, so what we're going to be doing today is we're going to describe these motion graphs using terms like walking away, stopping, slowing down, changing direction. We're going to do those, describe them in those ways. So what we have here is a graph. It says distance from home on the y-axis and time on the x-axis. That's always your first step when you're analyzing a graph, is what is your y-axis, what is your x-axis. The reason is because that tells you what you're looking at. What we're looking at is the distance traveled from home, right? Because distance is increasing as we move up the y-axis over a period of time, because time is increasing as we move across the x-axis. And we read it like we read a book, from left to right. So in this graph, distance is increasing away from home, and then this looks like it's going down. So the distance is starting to decrease, okay? Going back toward home. Home is y equals 0. Home is this line. Home is 0, okay? They change direction here and they start walking away. So the direction of the line indicates their distance increasing from home or from 0, okay, over a period of time. So we will describe this line as walking away from home because the distance from home has increased. This point is a very high distance from 0, okay? So they walked away from home. This little point right here, they changed direction. So if I asked you to, and you had numbers on this graph, you would be able to calculate the velocity at this point, because velocity is speed with direction. This is how fast this person is moving away from home over time. This line is this person's speed as they leave home. Here, they change direction and they go back toward home, okay? So they're going towards 0, towards home at a certain speed. And at this point right here, they changed direction again and they began to walk away from home. So their distance is still increasing away from 0, okay? Are there any questions about what I just said? Now with this graph, we have a curved line, okay? This is telling me that his speed is not constant. His speed is not the same distance over time. So his speed here at this distance and at this time is different than his speed here. Let me do that. His speed here, which is distance divided by time, y over x, is going to be different than here because the time and the distance are so different. It's not constant, okay? Where if we look at another graph where it's linear, it's going to be the same rise over run every time, okay? Gradually increasing in speed right here. And then what happens here? What's happening right here, guys? He started moving here. So at point 0, he starts moving. But this line, if you look, he's starting to cover less distance over time. So let's, from this point to this point, that's as straight as it's going to get. Look how much his distance increased. It didn't increase by much, but the amount of time increased by quite a bit, okay? So good. He's slowing down right here, okay? And then who remembers what I said about a horizontal line? What's happening right here at this line? Horizontal line, he stopped, okay? So at this point, he started moving. And about the middle, he started to slow down. And then at the top, We have a horizontal line, which means his distance is not changing over time. There's no change in distance. That means he stopped. Okay, right here, we have another story. So how would we describe this line? How would you guys describe this line? Is he moving slowly? Is he moving fast? Or is he stopped? He's moving slowly here. He's moving slowly here because this line is not as steep as this line. This top line right here is indicating that he is covering more distance over time. Therefore, he's moving faster. Because this line is steeper than this line, he's covering more distance over time. Therefore, he's moving faster. He's covering more distance in less time, I should say. Whereas this person, this moment in time, he's not moving very fast. Okay, so he's not moving fast here because the line is not as steep. So the steeper the line, the faster the motion. Very good. All right, so let's move our vocabulary words. We said this line is moving slowly because it's less steep. This line is indicating that there is no change in distance over time. So if there's no change in distance, is the object moving? No. When you have a horizontal line, it means the object is at rest or stationary. There is no movement, so he is stopped. This line is very steep compared to the first line, so that indicates that he's moving fast. Now, this is one of my favorites to associate a story with, okay? So keep in mind that we're tracking the speed, which we find from the distance from home over time. So this person is walking away from home. I want you guys to visualize a hill, okay? When you walk up a hill, is your pace fast or slow? When you guys have to walk up a hill, your pace is slow. So notice how not steep this line is, how less steep. So I'm imagining a person is walking up a hill and they get to the top, and it's easier to walk on a flat surface. So they're walking on the top of this hill and they're walking a little bit faster because it takes less work. Then what happens when you walk down the hill? Good, you go faster. Okay? So this person is walking really slow right here. Their pace picked up right here. And it picked up a lot right here. This line is a lot steeper. So if we wanted to attach a story to this particular graph, you guys could say this person walked up the hill, this person walked across the hill, and this person ran down the hill. And what I want you to think about is this person went over an entire hill. Their distance from home still increased. They're still far from home. There's a whole hill in between them and home. Okay? So the first line, they are crawling. It's a good indicator of how slow they're moving. The second line, they're walking. And the third line is running because the speed is higher here and their speed is increasing as they walk across this hill. Okay, so again, let's tell a story. This person is moving pretty quickly away from home. They stopped for a significant period of time, right? When I draw time, when I see somebody stopped, I always like to draw my lines down so that I can show that their distance didn't change for a long period of time, because time's still going on. All this time passed before this person started moving again. Okay, so they were leaving home, they stopped, and then they went back home. Okay, because remember, y=0 is home. That's home. So I want you guys to tell me which line is faster, line 1 or line 2. Who has the faster speed? Did he leave home faster or return home faster? The steeper the line, the faster the motion. Is this line more steep than this line? This line is not more steep. The answer is 2. Let me erase all these marks so you can see that. So when there is less time, equal distance, okay, same distance, this person used way more time to get from this point to home than on this time. So from this point to home, they took less time when they returned. So when distance is equal, the smaller time will give you the higher speed, the faster speed. The faster speed, not higher. He left home, he stopped for a long time, and he returned home quickly. Okay, so here we have some curved lines. So let's talk about each part one at a time. Here, we're gradually covering more distance over time. So how will we define that? We're gradually covering more distance over time. Okay, let me erase so you can see the line. So he's slowly picking up speed. The line is slowly becoming steeper. So this line gradually gets faster. But then what happens right here? He starts covering a whole lot less distance over time. So if you're not covering very much distance over time, are you going fast or slow? Good. He decreased his speed. So he's gradually picking up speed, and then he got really slow, and then whoosh, he got really fast. Okay? This graph is showing a constant change in his speed and direction. So what kind of line is this if there is a change in speed or direction? This is showing his acceleration. His speed and direction are constantly changing. Okay, so here, this line is going away, distance is increasing, so he's going away from home. Which line is steeper, the first line or the second line? So by saying this line is steeper, we're saying that the speed is higher. Okay, so something you can look at is this person's running away. Running is a faster pace, so they're running away from home. They stopped for a long time because distance isn't changing. And then they walked home. And I say walked because the speed of this line is slower than this line. This line is not as steep, therefore the speed is slower. And this graph looks pretty similar as well to the one we just did. They're leaving home, they stopped, and they're going home. Okay? Their distance is increasing from home. They stopped, and then they went home. Now, I love telling a story with this one. So get creative and let's think. This person is leaving home at a steady pace. Then they changed direction right here. Okay? So they changed, and then they had to hurry back. And they went all the way home. So think about a story you could tell with that. And then they ran away again. Okay? So let me erase all of that. So they leave home. They run back home, and they leave again. Okay? So they leave home slow, because this line isn't as steep as this line. Okay? This line's closer to being vertical up and down than this one is. They had to go all the way back home, and then they left home faster than when they left home the first time. They leave home faster in this line. Okay? What do you think's happening with this story? So this story starts somewhere else, not at home. We said the store. So they started at the store, and they are returning home at a constant rate. Okay? They're returning home at a constant rate. This line going down indicates a decrease in distance. Okay? Distance decreased, not speed. Just because the line is pointing down does not mean they have a slow speed. This person was at the store and came home at a constant speed. Okay, so we have a crazy graph right here. We have somebody going away from home. They're walking away from home. Walking away from home. What is this? What's happening there? Time stopped. So at this point in time, at this point, time stopped increasing, but distance didn't. It's saying that this person is here and here at the same time. Is that possible? So right here, we have two distances, two y's for one x. We have two distances at the same time. So this graph is incorrect because time does not stop. So they're saying that time stopped right here. And then they said they started walking again. But this graph is incorrect because time does not stop. Time does not stop.